Hello guys, Assalamu alaikum, Bismillah Rahmanir Rahim. Today another lecture we are going to start determinant of a matrix. So what is determinant of a matrix? Let A is equals to A, B, C, D be a square matrix of order 2 into 2, 2 rows and 2 columns. Then determinant of A is denoted by det of A, or A determinant A mod is equals to A, B, C, D and mod. This is how to represent the determinant, but how to define a determinant is this will be equals to AD multiply A with D, the diagonal elements, minus B with C, minus BC, always minus sign between them. Okay, so AD minus BC is called A determinant of the matrix A. And after finding the determinant, AD minus BC will also be a real number, so belongs to a real number. So this is how to define determinants of a matrix. Again, let A equals to A, B, C, D is a square matrix of order 2 into 2. Then its determinant is denoted by that of A is equals to A determinant or A mod, and is defined as AD minus BC. Let's see an example for this one. For example, we have a matrix A is equals to 1, 2, 3, 4, for example, square matrix of order 2 into 2. So A determinant will be equals to A times 4, which is 4, minus 3 times 2 is 6, so which is minus 2. So this is how to find the determinant of a square matrix of order 2 into 2. So always we will take a square matrix of order 2 into 2. Otherwise, to find the determinant of order 3 into 3 is different. So that is out of syllabus, so we will not discuss order 3 of 3 here. Next is singular and non-singular matrices. A matrix A is said to be singular if its determinant is equals to 0, and a square matrix A of order 2 into 2 is said to be non-singular if its determinant is not equal to 0. For example, we have a singular matrix like, let's take A 1, 2, for example, 2 and 4. This is matrix A. So what is its determinant? Its determinant will be equals to 1 times 4 is 4, minus 2 times 2 is 4. So 4 minus 4, 0. Since A determinant is 0, so A is singular matrix. Now let's see another example. As I did before, A equals to 1, 2, 3, 4. So its determinant is 4 minus 6, which is negative 2, which is not equal to 0. So if A determinant is not equal to 0, so it means A is non-singular. So A is non-singular. Non-singular matrix. Okay. Next is adjoint of a matrix. So how to find adjoint of a matrix A? So let there is a matrix A equals to A, B, C, and D. This is a square matrix. So its adjoint is denoted by A, D, J, adjoint of A, and is defined as, how to find adjoint of A is interchanging the position of the diagonal elements AD. So instead of A we will write D here, and instead of D we will write here, interchanging the elements of the main diagonal and the signs of the other elements. Here it is plus B, so we'll write minus B. Plus C will become minus C. So this is determinant of A. For example, A is equals to 1, 2, 3, 4. Then its adjoint of A will be equals to, then its adjoint will be equals to, let's take minus here, minus 2 and minus 3. So what will happen? Interchange the main diagonal. 1 bring here, 4 take there. Okay. So it will be 4 into 4 and 1. And the sign of minus 2, which is plus 2, and change the sign of minus 3 will be plus 3. So this is how to find adjoint of A. So next is inverse of a matrix. The inverse of a matrix A is denoted by A inverse and is defined as adjoint of A upon A determinant. So this is the formula to find inverse of a matrix. Inverse of a matrix only exists if and only if A determinant is not equals to 0. Means if A is non-singular matrix. Inverse only exists if and only if A is non-singular. Non-singular. Inverse will not exist if A is a singular matrix. If A determinant is equal to 0, means if A is singular, then A inverse doesn't exist. Why? Because see, if A determinant is 0, A inverse will be equals to whatever we have adjoint of A. If A determinant is 0, which is undefined. So that's why inverse of only non-singular matrix exists. Singular matrix inverse will not exist. Okay. So I will give you example in exercise how to find inverse of a matrix. We know how to find the adjoint of a matrix and we know how to find A determinant. Just we will divide adjoint of A by A determinants, then we will get A inverse. Moreover, if you multiply A with its inverse and its commutative also, or A inverse with A, you will get identity matrix. And you know what is an identity matrix of same order 1 0 0 1. So this identity matrix order will also be 2 into 2. There is one property of inverse of a matrix. So let A and B are two matrices. They are non-singular and square matrices of the same order. Then AB whole inverse is equals to B inverse into A inverse. This property we will prove in exercise. So here A and B are non-singular, square matrices, and square matrices. Remember that the inverse of identity matrix is always identity. Okay, so inverse of identity matrix is always an identity matrix.
Next is exercise 1.5.
So in question number 1, it says that find the determinant of the following matrices. So what will be the determinant of A? A determinant will be equals to -1 into 0, which is -1, and -2 times 1 is 2, which is -3. Similarly, B determinant will be equals to 1 times -2, which is -2, and -3 times 2 is 6, so which is -8, -8. Number 3, you can find C determinant. C determinant will be equals to 3 times 2, 6, -3 times 2 is 6. 6 minus 6, 0. You can see C determinant is 0. So since C determinant is equals to 0, so you can see C is a singular matrix. Singular. And let's find D determinant. D determinant is equals to 4 times 3 is 12, minus 2 times 1 is 2, which is 10. D determinant is not equal to 0, so D is, you can say, non-singular. They are just asking how to find the determinant, so we found the determinants. If they will say which one is singular or non-singular, you can tell that one also. Like in the next question, he's saying in question number 2, find which of the following matrices are singular and non-singular. So what is the condition to find singular, non-singular? We need to find its determinant. So first one, A determinant is equals to 4 times 3, 12, minus 6 times 2 is 12. Since A determinant is equals to 0, so we can say A is singular. Singular. B, what will be B determinant? 4 times 2, 8, minus 3 times 1 is 3, which is 5, which is not equals to 0. So B is non-singular. This B will be non-singular. What's about C determinant? This is part 3. C determinant 7 times 5 is 35, minus negative 27, yeah. So 35 plus 27, so 2, 1, 62, which is not 0, which is not equal to 0. So this one is also non-singular. D determinant will be equals to part 4. 5 times 4 is 20, minus 10 times minus 2, which will be plus 20, yeah. So which is equals to 0. So D is singular, okay. We will not say that D determinant is singular, rather D is singular. Question 3 says find the multiplicative inverse if it exists of each. If it exists means if determinant of a matrix is equals to 0 and it will be singular, then its inverse will not exist. So that's why it's written here if it exists. So first of all, let's find A determinant. A determinant will be equals to, multiply this with this, minus 1 with 0 will be 0, and 2 with 3, minus, you know, when we are finding determinant, we will use minus sign. So 3 times 2 is 6. So which is minus 6. And it's not equal to 0. So A is non-singular. So its inverse exists. Since A determinant is not equal to 0, so A is singular and its inverse exists. Now you know how to find A inverse. The rule is A inverse is equals to adjoint of A over A determinant. So what is adjoint of A? Adjoint of A, you know, to interchange the position of the main diagonal. So here it will come 0, minus 1, and we can get it by changing the signs of other elements. So 3 will become minus 3 and 2 will become minus 2. And down we have A determinant, which is minus 6. So we can write like this: minus 1 over 6, 0, negative 3, negative 2, negative 1. So this is A inverse. This is your answer. You can verify this answer. You can check A inverse equals to I. If you multiply this matrix A with its inverse, you will get identity matrix of the same order, that is 2 by 2. Same like A, B part. First we will find B determinant, which is minus 5, minus 3 times 2 is minus 6. So it will be 5 plus 6, which is 1. So not equal to 0. So B is non-singular matrix. So its inverse exists. So what it will be? Its inverse. B inverse is adjoint of B over B determinant. What is adjoint of B? Same, interchange the position of these elements. So minus 5, 1, and sign of plus 2 will become minus 2 and minus 3 will become plus 3. And down we have B determinant. B determinant is 1. So if you divide anything by 1, you will get the same number. So this is our B inverse. Again, here you can verify or you can check. B into B inverse will be I. So this is your answer. C part. C determinant is equals to, multiply this with this, minus 2 times minus 9 is plus 18, minus sign 6 times 3 is 18, which is 0. So since C determinant is 0, so C is singular. So if C is singular, it means C inverse doesn't exist. So we cannot find C inverse because C determinant is 0. So when you divide adjoint by 0, it will be undefined. That's why. So what is D? D is this one. So D determinant. Multiply this with this. 1 by 2 times 2 minus 3 by 4 times 1. So you will get 1 minus 3 by 4. Down here we have 1, multiply 4 with 1, we will get 4. Cross multiply, so 4 minus 3, which is 1 by 4. So this is our D determinant. Now what is D inverse? Because it's not equal to 0, its mean inverse exists. D is also non-singular. So D inverse will be adjoint of D over D determinant. Adjoint of A is interchanging the position of these two elements. So it will be 2 into 1 over 2 and the sign of other elements 3 over 4 and minus 1. So this is adjoint of D over D determinant. D determinant is 1 by 4. We can do here, this 4 will go up, and 2 minus 3 by 4 minus 1 and 1 over 2. We can multiply this with each element. So finally we will get 8 and minus 3, negative 4 and 2. So we got D inverse as 8 minus 3 minus 4 and 2. You can also verify here by checking this property D into D inverse is equals to I, or you can check D inverse into D equals to I. Both will be identity matrix. In this question, we need to prove that A times adjoint of A is equals to adjoint of A times A is equals to determinant into identity matrix. All three are equal. So let's take first one, which says that A into adjoint of A. We need to multiply both. So A is, here we have 1, 2, 4 and 6. What is adjoint of A? Adjoint of A will be 6, 1. You need to change the interchange the position of the diagonal elements, these, and the sign of other elements. Change the sign of other elements. So this will become minus 2 and minus 4. Now we need to multiply. You know how to multiply two matrices. This row you will multiply with this column. So 1 with 6, you will get 6. 2 times minus 4 is minus 8. Similarly, 1 with minus 2, you will get minus 2. I am multiplying first row with second column. So 2 with 1, you will get plus 2. Again, second row with first column, 4 with 6 and 6 with minus 4. 6 times 4 is 24 minus 24. Similarly, first row with the second column, so 4 will multiply with minus 2, will get minus 8, and 6 will multiply with 1, so we'll get 6. And this will be equals to minus 2, 0, 0, minus 2. So we got A into adjoint of A. This might say this is 1. Now we need to find adjoint of A times A. Adjoint of A, we need to multiply adjoint of A with A. So what is adjoint of A? 6, 1, minus 2 and minus 4. Same like before. 6, 1, minus 2 and minus 4. This is adjoint of A, and what is A? A is 1, 2, 4, 6. Multiply first row with this column. So 6 with 1, 2 with minus 4. So 6 minus 8. First row with second column. So 6 with 2, 12, and minus 2 with 6. So minus 12. Similarly, second row with first column, minus 4 with 1, you will get minus 4, and 1 with 4, you will get plus 4. Again, second row with second column, so this minus 4 will multiply with 2, so it will become minus 8, and 1 will multiply with 6, you will get 6. So we have minus 2, 0, 0, minus 2. This is our equation 2. Now we need to find third one. Determinant of A multiply with I. Determinant of A is multiplying with identity matrix. So what is determinant of A? A determinant is equals to 6 times 1 is 6 minus 4 times 2 is 8. So we will get minus 2. Minus 2 is multiplying with I. Identity matrix 1, 0, 0, 1, or ask here identity matrix of order 2 into 2. So when you multiply, you will get minus 2, 0, 0, and minus 2. From equation 1, 2, and 3, you can see 1 is equals to 2, 2 is equals to 3. All three got the same answer. So we have verified. Or let's see how to solve part 2. So to find B into B inverse, first of all we need to find B inverse. So What is B inverse? B inverse, you know, it's adjoint of B over B determinant. So what is adjoint of B? Just interchange the position of main diagonal elements of these two elements, -2 and 3, -2 and 3, and the signs of other elements. Change the signs of other elements. So -1 become +1 and 2 will become -2. What is B determinant? B determinant you can find separately here. 3 times -2 is -6, minus 2 times -1 is -2. So -6 plus 2 is -4. -4 you can divide here, and you can write this as -1 by 4 into -2, 1, -2 and 3. This is our B inverse. But we need to find B into B inverse. Multiply B with B inverse. What is B? B we have 3, -1, 2 and -2. Multiply this with inverse. Inverse is -1 over 4, -2, 1, -2 and 3. -1 over 4 you can write outside. Just multiply 3 minus 1, 2 and -2 with -2, 1, -2 and 3. So -1 by 4, we will get 3 times -2 is -6, -1 times 1, -2 is +2, and 3 times 1 is 3 and -3. Same, 2 times -2 is -4, and this one will be +4. 2 times 1 is 2, and 2 times 3 is -6. So we will get here -1 by 4. B into B inverse equals to -1 over 4. 6 minus 2 is 4. -6 plus 2 is -4, 0, 0, -4. -4, 0, 0 and -4. So when you will divide or multiply with this, you will get 1, 0, 0, 1. So B into B inverse is identity matrix. This part we have proved. Now we will prove this one. If we will multiply B inverse with B, what we will get? Now again, B inverse into B, what we will get? What is B inverse? We just found there. B inverse is -1 by 4, -2, 1, -1 by 4, -2, 1, -2 and 3. And what is B? B we have 3, -1, 2 and -2. So we'll just multiply this. -1 by 4, -2 into -3, -6, 1 into 2 plus 2, -2 into -1 plus 2, with -2 will be -2 here. Say -2 with 3, -6, plus 6, and minus plus, -2 times -1 is 2, and 3 times -4, -2 is 3 times -2 is -6. So we got -1 over 4, -4, 0, 0 and -4. So when you will multiply, you will get 1, 0, 0, 1. This is B inverse into B, which is also identity. So we have proved this one also. In question number 5, it says that determine whether the given matrices are multiplicative inverse of each other. You know the condition for multiplicative inverse. Two matrices A and B are multiplicative inverses of each other if and only if A in AB equals to I. So if these matrices are inverse of each other. So when we multiply this with this or this with this, we should get identity matrix. Then these matrices will be multiplicative inverse of each other. So we will just multiply and prove that identity matrix is coming. So once we will get identity matrix, it's mean these two will be multiplicative inverse of each other. So multiply this with this, 3 times 7 plus 5 times minus 4 and 3 times minus 5, first row with second column, plus 5 times 3. You know how to multiply. We have done in the previous videos that how to multiply two matrices. Now second row will multiply with first column, 4 into 7 plus 7 into minus 4. Similarly, second row with second column, 4 into minus 5 plus 7 into 3. So we will get 21 minus 20 minus 15 plus 15, and 7 times 4 is 28 minus 28. 5 times 4 is minus 20 plus 7 times 3 is 21. So we got 1 0 0 1, which is identity matrix. So in part 1 both are inverses of each other. Yes, both are inverses of each other, both matrices. Let's check part 2. In part 2, say multiply first row with first column. So 1 into minus 3 you will get minus 3. 2 times 2 is 4. 1 times 2 is 2. 2 times minus 1 is minus 2. Again second row, 2 times 3 is minus 6. 3 times 2 is plus 6. 2 times 2 is 4. Minus 3 times minus 1 is minus 3. So which is equals to 1 0 0 1. If identity matrix will not come, then it's mean these are not inverses of each other. But again we got identity matrix, so it's mean yes, both matrices are multiplicative inverse of each other. So like this we will prove that two matrices A and B are multiplicative inverse of each other if after multiplication we will get identity matrix. Okay, question number 6 says that if A, B and D there are three matrices, then verify that AB whole inverse is equals to B inverse into A inverse. Let's say this is left hand side and this one is right hand side. So first let's take left hand side. Left hand side is AB whole inverse. So first we need to find AB. A multiply with B, then we need to find its inverse. So how to find AB first? You know, multiply A with B. So this will be 4 multiply with minus 4 and 0 multiply by 1. 4 times 4 is minus 16 plus 0 times 1 is 0. Similarly, first row of A will multiply with second column of B. 4 will multiply with minus 2, it will be minus 8, and 0 will multiply with minus 1, which is 0. Similarly, second row of A will multiply with first column of B. We will get minus 1 times minus 4 is plus 4, and plus 2 times 1 is 2. Again, second row of A will multiply with second column of B. So minus 1 will multiply with minus 2, so it will be 2, and plus minus 2 times minus 1 is 2. So AB will be equals to minus 16 plus 0 is minus 16, minus 8, 4 plus 2 is 6, and minus 2 plus 2 will be 0. Now AB whole inverse will be equals to adjoint of AB divided by AB determinant. So what is AB determinant? First let's see. AB singular or non-singular. AB determinant is equals to, multiply minus 16 with 0, you will get 0. Minus always, so 8 times 6 is 48, negative 48. So this will become plus 48. So this is our AB mod, which is not equal to 0. So AB is non-singular. Its inverse is possible. Is adjoint of AB. Adjoint of AB, by replacing by interchanging the main diagonal, we will get 0 minus 16 and sign of other elements. So minus 8 will become plus 8 and 6 will become minus 6. This is adjoint of AB. And down we have, AB mod, which is 48. Its determinant. So we got AB whole inverse is equals to 1 by 48 and 0, 8, minus 6 and minus 16. And you can further multiply 1 by 48 with 0, you will get 0. So 1 over 48 times 8. 8 times 6 is 48, so it will come 1 by 6. So minus 6 times 8 is 48, so here minus 1 by 8, and 16 minus 16 divided by 48 will be 1 by 3. So this is AB whole inverse. You can say this is equation number 1. Okay, now we will find right hand side. Right hand side is B inverse into A inverse. So let's take right hand side, which is B inverse into A inverse. What is B inverse? First we will find B inverse, then A inverse, then we will multiply both. So how to find B inverse? B inverse is adjoint of B over B determinant. What is B determinant? First, to see whether it is singular or non-singular. B determinant of B is minus 4 times minus 1 is plus 4. Minus 2 times 1 is minus 2. So this will be 6. So it is non-singular, so its inverse is possible. So adjoint of B, what it will be? Adjoint of B, changing the position of these elements of the main diagonal, minus 1 to minus 4, and changing the sign of other element, minus 2 will become plus 2 and 1 will become minus 1. So this is our adjoint of B. And down we have B determinant, which is 6. So we got B inverse as 1 over 6 into minus 1, 2, minus 1 and minus 4. Now let's find A inverse. Let's take A mod first. What will be A mod? A mod will be 4 times 2 is 8. 0 times minus 1 is 0. So this will be 8, which is also singular. So A inverse will be equals to adjoint of A over A determinant. Adjoint of A is 4 and 2, change the position, 2 and 4, and minus 0 doesn't matter whether it is positive or negative, it will be 0. Minus 1 will become plus 1, and determinant A determinant is 8. Finally we will have A inverse is equals to 1 over 8, 2, 0 and 1, 4. So now we need to multiply B inverse with A inverse. So B inverse is 1 over 6. What will be B inverse into A inverse? Since B inverse is 1 over 6 into minus 1, 2, minus 1, 4, minus 1, 2, minus 1 and 4 times A inverse is 1 over 8, 2014, 2014, and this one is negative here. Now you can multiply first this one 1 by 6 with 1 by 8, and two matrices you need to multiply minus 1, 2, minus 1, minus 4 with 2, 0 and 1, 4. So you will get 1 over 48, and here when you multiply this row with this column, minus 1 into 2 is minus 2, plus 2 into 1 is 2. Similarly this row, the same row with second column, minus 1 into 0 is 0, plus 4 times 2 is 8. Now second row, minus 1 into 2, which is minus 2, minus 4 into 1 is minus 4, minus 1 to 0 is 0, minus 4 times 4 is 16. So we will get 1 over 48 into 0, 8, negative 6 and minus 16. So when you will divide or multiply 0 with 1 by 48, you will get 0. 8 times 1 by 48, which is 1 over 6, and here minus 6 divided by 1 over 8, minus 1 by 8, minus 16 over 48, which will be minus 1 over 3. This is our equation 2. Let's see 1 is matching with 2 or not. 0, 1 by 6, minus 1 by 8, minus 1 by 3. And here we have 0, 1 by 6, minus 1 by 8, minus 1 by 3. Is it same? Yes. So this is our B inverse into A inverse. Since 1 is equals to 2, so left hand side is equals to right hand side. So we have verified that AB whole inverse is equals to B inverse into A inverse. So verified that left hand side is equals to right hand side. So this is the answer of this one. So likewise part 2, take left hand side, this is left hand side, say this is right hand side. So left hand side of part 2 is equals to dA whole inverse. Now dA will be equals to D times A. Matrix D is multiplying with A. So what is A? A is 4, 0, minus 1 and 2. So just multiply, you will get 3 times 4, 1 time minus 1, 12 minus 1, 3 times 0 is 0, and 1 time 2 is 2. A minus 2 into 4 minus 8, 2 into minus 1 minus 2, and 2 into 0, minus 2 into 0 is 0, and 2 times 2 is 4. This is how you will multiply. So what will be AB? AB will be 11, 2, minus 10 and 4. Now we will find its inverse. Now dA inverse will be equals to, this one is dA, adjoint of dA over dA determinant. What is dA determinant? dA determinant is 11 times 4 is 44, minus 10 times 2 is minus 20, which will become plus 20. So this will be 64. This is DA determinant. So adjoint of DA will be, changing the position of these two numbers and interchanging the signs of other numbers. So 4, 11 and minus 2 minus 10 will become plus 10. And this is DA is 64. So down you can write here 64, 1 over 64. So this is DA whole inverse. Say this is equation number 1. Now you need to find A inverse and D inverse. So what will be A inverse into D inverse? Let's copy this one on the next page. So A inverse into D inverse, right hand side you can take, which is A inverse into D inverse. So to find A inverse, first A inverse equals to adjoint of A over A determinant. Here we can find A determinant as 4 times 2, 8 and minus 0. So which will become 8. Use here adjoint of A. Adjoint of A is changing the position of the diagonals 2, 4 and other numbers. Sign you need to change. 0 you can write positive or negative, doesn't matter. So adjoint of A divided by 8, so which will be 1 over 8, 2, 0, 1 and 4. This is A inverse. Now what is D determinant? D determinant is equals to 3 times 2, 6 and plus 2, 6, minus 2 times minus 2, so it will be plus 2, 6 plus 2 will be 8. This is our D determinant. So now D inverse will be equals to adjoint of D over D determinant. What is adjoint of D? Adjoint of D is changing the position of these two diagonal elements, so it will be 2 and 3, and the signs of other elements will, 1 will become minus 1, minus 2 will be plus 2. This is adjoint of D, and over D determinant is 8. So D inverse will be equals to 1 over 8 into 2 minus 1, 2 and 3. Now we need to multiply A inverse with D inverse. So A inverse into D inverse. What is A inverse? A inverse is 1 over 8, 2, 0, 1, 4. 1 over 8, 2, 0, 1, 4. 2, 0. What is B inverse? 1 over 8, 2 minus 1. 1 over 8, 2 minus 1 and 2, 3. So like we did in the previous question, multiply this with this, you will get 1 over 64, and just multiply the matrices. 2 with 2, so 4. 0 with 2, 0. 2 with minus 1, minus 2. 0 with 3, 0. This row we have multiplied with this one, and the same row we multiply with this column. 0 into 3 is 0. Similarly, this row will multiply with first column. 1 into 2, 2. 4 into 2, 8. Again, second row of the first matrix multiply with the second column of the second matrix. So 1 into minus 1 will be minus 1. 4 into 3 will be 12. 1 times will be minus 1. So we'll get 1 over 64. 4 minus 2, 8 plus 2, 10 and 11 here. So this is our A inverse into D inverse. Equation 2 is same as 1 over 64 4 minus 2 10 11. So 1 over 64 4 minus 2 10 11. So 1 and 2 are same. Since because 1 is equals to 2, it's mean left hand side is equals to right hand side. That is, this is therefore, and this is that is DA whole inverse is equals to A inverse into D inverse. Hence verified. Hope you understood all exercise. See you next time, inshallah. Thank you very much. Have a nice day.